Good morning, everyone. I'm Guy Payne, the Director of the Sustainable Energy Outreach Network, SEON for short. This is our 6th year hosting the Sustainable Home Tour. And now, because of the pandemic, we've decided to continue this format. This gives us the benefit of reaching more people than in Southern Vermont, showcasing more homes outside of Windham County. And we're not reliant on the weather for our, in the past, road trips that we had taken. As in the past, our goal is to present the best practices in building construction as they pertain to processes, technologies, and products. We hope this tour will give you the information that you need and decisions that you need to make as they pertain to either new construction, renovations, or additions. Secondarily, we hope that the builders and designers, architects are able to see what our builders are advocating in the colder climates. We use the phrase high performance to signify homes that have given consideration to certainly not just energy efficiency, but durability, indoor air quality, water and vapor management, aesthetics, the right products, as well as aging in place. If you're new to SEON, here's a little background. We were formed in the aftermath of Hurricane Irene back in 2011. At that time, builders and weatherization professionals were concerned that they did not have access to the kind of information about how water and vapor management impacts energy efficiency. I facilitated a meeting with the builders and weatherization folks with Peter Yost to design and deliver an advanced training program on building science. And for some of you who are new to that concept, building science very simply is the physics of how air, heat, and moisture move through a building. Our first class was in November of 2011. In 2012, we became incorporated as a nonprofit, and in 2015, we became designated as a 501c3. Our mission is to expand the knowledge base essential for high-performance building professionals, as well as engaging the community in building a clean economy. In essence, we are a professional development and educational organization. Our keynote achievement is the introduction of a high-performance certification program for incumbent and entry-level workers. Today's format for each project will follow a similar sequence, with me introducing the project, followed by a 10-minute video presentation about the home, and then followed by short clips from our advertisers and sponsors. It's their generosity that has enabled us to offer this program. Then after that, the builder will answer your questions. And we ask that you type in your questions into the Q&A box that's at the bottom of your screen. Well, certainly while the video is playing. And when the video finishes, the questions will be read to the builders and architects for their response. This program will be and is being recorded. And before we move forward, I do need to recognize key individuals who have been part of this production. Tom Hutton compiled and edited the videos of the Cliff House and the Resurrected and the Deep Energy Retrofit, or sometimes we say Resurrected House, one and the same. Graham Dennison and Jennifer Martin of Hempstone provided their own video for the Fuller Road House, and SEON's indomitable program manager, Teresa Spear, for her tireless and detailed shepherding of this project. Teresa and Neil Goldberg, a SEON board member and member of Berkeley and Veller, for their technical guidance actually during this presentation, and our planning team consisting of myself, Teresa, Neil, Gary Swindler, and Jonathan Morse. Before we go to the videos, I'd like to take a moment and survey who is really in attendance. Where is your location? We're interested in knowing the breadth of our publicity. And secondly, how are you participating, either as a homeowner, a builder, designer, consultant? Let's begin with the first question. You will see a pop-up screen with a location question. Please provide an answer, and I'll wait a few minutes to record, and then I'll come back and give an answer. Okay, if we could end the poll, let's wait a few moments and see what the results are. Looks, wow, okay. 67% from Vermont, another 26 from New England, the Southeast, as well as the Midwest. Wow, okay. That's good to know. Interesting. Okay, let's go to the second question. Your interest. Please do the same as the pop-up appears. Okay, let's end the pop-up. Let's see the results. Almost 60% are homeowners interested. Okay, 14, a nice, very nice blend of the interested folks. So we touched a number of folks, so that's an interesting blend. Okay. We're blessed in New England, in certainly southeastern Vermont, with high-performance builders who take the responsibility of continuous learning, mentoring, and promoting sustainable design and construction. Many of these builders are members of SEON, and they made this home tour possible with their donations. So before we begin our program, I'd like to take a few minutes to recognize these builders.
For 30 years, Dave Carter has been fashioning aesthetic solutions in solid wood. Nest Woodworking is looking for opportunities with which to continue the adventure.
Hello, this is Scott Mathis from Mathis Hume Builders. We are a full-service construction company specializing in thoughtful renovations and high-performance new construction in the Southern Vermont region. Our mission is to help clients realize their dreams while taking into account the budget, schedule, and aesthetic goals of the project. We offer professional pre-construction and construction management services to ensure that the process of building your dream is as enjoyable as the outcome. Contact us today at mathishumebuilders.com to get started.
All Seasons Construction is a leading construction management general contracting firm based in Springfield, Vermont. From large commercial projects, including medical facilities, historic renovations, and institutions, to new custom homes and renovations, All Seasons can provide the management and services required for your project.
Mindell & Morse Builders creates beautiful, healthy, and comfortable homes that use little energy. Established in 1981, we pride ourselves in lasting relationships. Contact us for your new construction or remodeling project. Visit our website, mindellandmorse.com, and follow us on Instagram at Mindell & Morse Builders.
GPI Construction is located in Brattleboro, Vermont. We are a medium-sized general contractor and construction management firm, focusing on high-performance commercial construction for the Brattleboro community and surrounding areas. Our adventures have taken us to many area landmarks, including the new Groundworks Collaborative Drop-In Center, Headwater Precision, many projects for the Wyndham and Windsor Housing Trust, the Brattleboro Retreat, the Brattleboro Memorial Hospital, and many other area businesses. The stunning Groundworks Collaborative Drop-In Center on South Main Street boasts an air tightness rating of 0.026 ACH50 per square foot of exterior shell, or twice that of Passive House standards. The collaboration of the Sustainable Energy Outreach Network, the High Performance Building Program, BVH Integrated Services, and our fantastic superintendent and team of subcontractors made this look easy. We are building the next generation of high-performance commercial buildings.
There's so many things about a building that should be lifted, not just for Unity clients, but really for everyone. In the Unity proposition, we're simply trying to demonstrate what buildings should be to better serve people and their families and the planet and future generations and the community and the neighborhood and the country. They're all connected.
First on the home tour is the Cliff House by Earthshare Construction and Back Tilt Studio. This high-performance Energy Star building was built to meet the needs of a mother and her children in a healthy, comfortable, and environmentally sensitive way. The aesthetic is simple and elegant, with an emphasis on flow and function. Remember to submit your questions using the Q&A button at the bottom of your screen.
Hello, welcome to the SEON Virtual House Tour 2021. Thank you to SEON. It's an honor to be here. My name is Ethan Cole. I'm with Earthshare Construction. We're based in Lebanon, New Hampshire. We're here to talk about the Cliff House that we recently completed in Norwich, Vermont, with one of our partners, Back Tilt Studio.
Hi, and I'm Dan Hedrick. I was the designer for this house. I specialize in small, energy-efficient homes. This one was a real joy to work on. It was a joy to work with Earthshare Construction, and I think we can say we're both quite proud of the result.
Absolutely. This house, which we're calling Cliff House, was a great project to work on, and it was great to work with Dan again. The story of the house is something like this. We needed to create a home for our client and her 3 school-age children. On the family property was an existing garage. Originally, the plan was to renovate the garage, but we discovered the slab the garage was on was not adequate. And so what was a gut renovation turned into a new construction project. But we had to stick with the existing footprint. Or at least we ended up sticking with the existing footprint for budgetary reasons, as well as site constraints. It is a 1,280 square foot house, 2 stories. It was built for about $250 a foot. It was a squeeze, but it is a modest home. And so the design and finishes followed modesty and simplicity that was refreshing and an alternative to a lot of the aesthetic visions that drive many projects these days.
Yeah, I think what's sort of key about this house is the simplicity of the systems, the simplicity of the build system, and finally, to get to cost, the simplicity of the form. So we'll probably talk a bit more about the systems, but in general, we have a double stud wall, heat pump for heating, pellet stove for backup, and probably a little unexpected for this house, but it's there, is a heat pump hot water heater, the new Sandon unit, which takes the heat for the hot water from the exterior and not the interior.
So now to get into a little bit more into some of the specifics of the house.
So let's start with the envelope. This is double stud wall designed to dry both inward and outward. Building is on a slab. On sub-slab R32, slab edge R42. There's a shelf there for that foam. And then we run up the wall with that double stud wall R41 and a scissor truss for R60. Windows are from Coltech, they're triple glazed. Ethan and crew did a superb job with the taping to get a fantastic blower door test, and he can tell you about that.
Final blower door test was conducted by Jen Severett of Efficiency Vermont. We participated in their high performance home program and achieved the highest tier. 174 cubic feet per minute was our blower door number, which equated to a 0.78 air changes per hour at 50 pascals. The threshold they require is 1. We were very happy with the 0.78. The roof is R60. The walls are R41. Some of the other requirements that Efficiency Vermont asks for have to do with Energy Star appliances, low flow water features, water sense, and water fixtures, as well as ventilation requirements. And so Dan can tell you a little bit about the mechanical systems that he designed for the most part.
So what we did, the prime heating source is a 12,000 BTU single head heat pump. The head is located in the prime living space on the ground floor. I assume that the heat will sort of wash up to the second floor to the bedrooms. For the really cold days, when you just need a blast of heat, we do have a pellet stove, also in that prime living space, and the bathrooms have small electric resistant heaters. So you do have a capacity to sort of get above the temperature provided by the heat pump. For whole house energy recovery ventilation, we just use a Panasonic unit. Works great. We installed that in a chase on the second floor with ducts running through the second floor walls down to the first floor as needed. Hot water, we mentioned, was a little unusual because we're on a slab and we just had no space for a indoor heat pump driven hot water heater. We opted to put a Sandin in. Has a fantastic warranty, so we're hoping that all works out well. Appliances obviously are efficient, Energy Star rated. All the lighting is LED. Overall, very low energy house. What's, I think, also really quite appealing about this place is its location. It's actually an in-town lot. It's part of a very small family subdivision. It's what I call location efficiency. In other words, the fact that the owner and her children can walk to school, to shops, to the bank. Really, in my experience, if you take the sort of net carbon consequence of our transportation footprint, getting these in-town locations is a huge bonus.
Yeah, absolutely. And I would add that the hot water heater, the Sandin, is one of the first on the market, if not the first, to use CO2 as the refrigerant, which is much more benign than your typical refrigerants used in heat pump systems. Some of which apparently always leaks out, and so that's a big plus. So to take a little bit of a closer look at the space, as I mentioned before, this house is refreshingly modest in the way it kind of reimagines what is really needed in a home. We did a custom kitchen built in our shop, and that's partly because this kitchen is small, and to hit the aesthetic, it just made sense. So we built this kitchen that Dan designed to maximize function while reducing or eliminating extraneous space and equipment. Most notably, it has a 2-burner electric cooktop that the homeowner has been raving about. It's fast, efficient, even for this family of 4. The refrigerator is small. The stackable washer and condensing dryer fit perfectly in a closet off the upstairs hallway. There is a built-in bench and shelves. They line the picture windows in the living room and the central upstairs bedroom. There's some built-in shelves centered in the stairway railing, accessible from both sides, and the deep windowsills serve as flexible shelves in each room for small items or even books and plants.
The whole goal with these small houses is you really try to make each little area connected to the whole, but simultaneously have a feeling of, let's say, difference from the other parts of the house. So in this case, we really accentuated the stair hall. It has a view of a cliff behind the house as you're walking up, so you have this micro experience of looking at quite a large stone outcropping. You turn, there's this bookcase element, top lighting. Each little area we try to make a little experience and effectively offset the fact that this is quite a small house by many people's standard, I guess is the best way to put it. So far, the owner's loving it. They're delighted.
Thank you so much for coming today. We would be happy to answer any questions if we have time, and feel free to reach out to us if you would like to discuss anything further. Thank you, SEON, and everyone.
If your old windows need tender love and care, call Thomas McLaughlin Window Repair and Weatherization, 254-9370.
Berkeley and Bellard Greenwood Country is the largest and oldest independent real estate agency in Windham County. We are family-owned, and our company culture is just that. We're a big family. We have fun together, and we work well together. Since 1965, we've helped thousands of buyers and sellers turn their real estate dreams into reality. Between our two offices, we have 28 agents. Our agents are a wealth of information and resources. The properties we've sold have a huge range from mobile homes and tiny houses, very small lots to hundreds of acres, antique houses and farms to stunning energy-efficient contemporaries, mom-and-pop storefronts to large commercial buildings. So, let us help you with your real estate projects and needs. Call or email, visit our website, have us work up a market value for your property, or help you find your next home. We are your real estate experts.
Hey Miles, our business is focused on providing our contractor customers with what is most important to them. Receiving deliveries that are complete and on time. From the initial sale through final delivery, our team takes care of it all, so you receive what you expect when you expect it. Celebrating our 80th year of delivering orders on time and in full. RK Miles, with full-service lumber yards throughout Vermont and Western Massachusetts.
Al Jefferson Sons Heating and Cooling specializes in energy efficiency, including both air and water source state-of-the-art heat pumps and equipment in southern Vermont. We provide diagnostic, design, and installation services to commercial and residential projects. We are members of Efficiency Excellence Network of Efficiency Vermont.
Proclima's IntelliPlus is the interior air barrier that makes the world's most efficient ecological buildings possible. More than simply an air barrier, it's a one-of-a-kind, vapor-variable smart membrane and dense pack insulation reinforcement all in one. IntelliPlus is a heavy-duty, passive house Class A air sealing component, surpassing ASTM E2357. It exceeds the most stringent standards for healthy indoor air quality and is Declare labeled. It's easy to install because it's lightweight, and with a reinforced mesh, It has a very high staple tear resistance, ideal for blow-in or dense pack insulation like cellulose, wood fiber, or sheep's wool. Using Intello Plus as part of the complete Proclima air tightness system is backed by a 10-year comprehensive warranty. It's available in 3 roll sizes: short, standard, and double wide. Intello Plus is the keystone to long-lasting air tightness and intelligent vapor control in walls and roofs.
Now we'll have about 15 minutes for questions and answers. And it's my pleasure to introduce Ethan Cole of Earthshare Construction and Daniel Heydrich of Backtilt Studio, who are available to answer your quick questions. Jonathan Morris, founder of Mindell and Morris and Vice President of SEON, will facilitate the questions and answers. Jonathan?
Hi, everybody. There are a number of questions, some of which are in the chat, and I'm going to remind people to put their questions, type their questions into the Q&A instead of the chat, so I don't have to look at 2 different dialog boxes, but we'll survive it here. So the first question is from Lisa Holderness. What is the overhang of this building, of the eave?
The eave overhang is 2 feet. So obviously the goal is just to keep that wall dry. For budget, it's vertical pine. You got to keep that stuff as dry as possible. So 2 feet.
Yeah. Okay. A question from, I'm not sure who, maybe it was Lisa. How is shear strength addressed in the large window corner?
The house is sheathed in plywood, and so shear was not a concern, I don't believe. But honestly, I'd have to check with my production manager to see if they did take any special measures. I don't believe it was a large enough window to necessitate any further shear reinforcement. Is that consistent with
Yeah,
your
I mean, we use, I think we both prefer just using plywood, and there's so much plywood on those walls, not a concern. There's 2 parallel bearing walls. If you think about the long walls are load bearing, then the truss free spans that. And those walls are, I think those went in 2 foot on center, if I recall correctly, but with plywood, and the trusses are dropped, if I recall correctly, right on top of the stud. So no concerns.
Okay, so Karen Bowman asks, what is the square footage of this house?
It's 1,280 gross square footage. So that's measured to the outside. I think if you actually took in all the wall thicknesses, I believe it's around 1,050. So 1,280 gross, i.e. including the 1 foot thick walls.
Okay, so you have a living space of approximately 1,000 square feet. Okay. A comment from Peter Bergstrom. It appears that an exterior door leads directly to the kitchen with no vestibule or mudroom. Did you consider adding a vestibule to reduce the cold blasts into the kitchen in winter? Our house has the same issue.
So that door was a last minute add. We were reviewing the window order, and there was intended to be a window there. The window got swapped for a door. So no, I hear what you're saying. That's how we ended up.
They probably won't be using that door a lot during the winter, and it's a very tight door, so it won't be drafty.
There were a couple of questions, one of which disappeared, about the water heater. does the water heater provide enough water on heat pump mode? And another question from Carol Hunter is the water heater. I'm a stickler about this. Is not a hot water heater. It's heating cold water. So it's a water heater. And is it on demand or is it a continuous?
It has a tank, so it has a storage tank, and we've had no concerns yet. They're a family of 4, so this is the first stand-in we've installed. But in talking with the distributor, they haven't had any issues that they reported to us when we dug, because we wanted to make sure that the hot water system would be adequate. So far so good.
Great. So, Ruth Bernars asks, what insulation materials did you use?
So we used the walls and roof where we know it's going to be dry is cellulose, lone cellulose. Sub slab is expanded polystyrene, which is you get very thick because of its R value. And there's a little bit of right where that slab butts into the wall where we needed high R value foam, so we get some coverage there. We used polystyrene. Sorry. Yeah.
Polyiso.
Polyiso, right. So foam, concrete down, cellulose or wood-based concrete up, wood at that concrete and up.
So I assume that the ISO is protected from getting wet?
It's all inboard.
Okay. Can you talk about the environmental control layers, vapor, air, moisture? How are they applied to ensure continuity? This is from Gary.
Sure. So the vapor barrier is the Intello on the interior face of the interior stud. It is caulked and taped to the slab, and it is connected through the floor system, through the joist system, using a paint-on product, a paint-on air barrier system over some wood blocking that had to go in between the joists. So the vapor barrier in the floor system was the trickiest part. Running the Intello up on the inside face of all of the framing, pretty straightforward, and that's all taped. On the exterior, the moisture management weather barrier is the Mento. It's a black vapor permeable but waterproof membrane that's applied over the sheathing and taped on the exterior. So yeah, that's the vapor and moisture and the air barrier. The primary air barrier is the exterior sheathing. We taped the seams of the sheathing. We also did the Mento over that and taped that. Our system, honestly, it may be a little bit too redundant. We've got a few different systems there. We spent a lot of time taping, but you do it for good reason, and we're happy with the result.
So I'm just going to comment. This is a fairly typical installation, and these 475 products seem to be working very, very well. Okay. Oh, you mentioned this, but maybe you could just say it again, the brand of the windows.
They're Coltech windows. Their strong card is triple glazing. They're vinyl. They're coming out of Atlantic Canada. They're very price set. They're very good value for the performance they offer. So Coltech.
So they are solid vinyl or what? Or are they vinyl clad?
No, they're solid vinyl. Front to back, they insulate between the extrusion. It's all German designed, but the factory is in Nova Scotia.
Okay, great. No, Roger Cooney asks, is the Coltec window UPVC? I don't know what that means.
I don't know. Sorry. Got me.
Anyone else in the audience know the answer to that? They can check in. So we've had a couple of in the chat and in the Q&A saying what a nice presentation you did. Talking about the simplicity of the form. I'm a big proponent of simplicity of form, so I appreciate that too. Part of this question is, are there any other things you did to keep costs down that stand out in your mind?
Yeah, I mean, one of the things, I'm sure we can run through a few. Let's see, one of the things we did is the upstairs, the subfloor is the finished floor. And so the owner painted the Advantech sheathing themselves. At the windows, we did window sills, but the other three sides of the windows are all finished in sheetrock. So we saved a little bit on trim costs there. Yeah.
Just keeping the framing really simple is the other thing. I think if we want to sort of expand the conversation to more general ground, I think the hardest part with this building, because of there's no basement, is the hot water. How do you get hot water in there? And that's where we settled on the sand-in, because we couldn't use a hot water heater, heat pump hot water heater that was going to be pulling heat from the interior. It just would have been so loud. I mean, where would we have put it? And you know, once you get the envelope really tight, that's kind of that's right there. In fact, there's 4 people living in there. I'm not so sure they're not going to consume more hot water than they are heat. Honestly, I'm not sure.
So we have a clarification about UPVC. All vinyl windows are UPVC. It just means unplasticized vinyl. So there you go. What is an element that was part of the original brief design that was removed from the final project, and why?
There was an entry porch that's not there now. Budget was really tight. So you were supposed to come up and have a small just roof over you before you entered. And that's designed but not built. And then honestly, to keep prices down, we just kept eating away at interior finishes. And that, I guess that's why I'm putting this hot water heater on the table, because that thing was not the cheapest option, but we think due to the warranty and its performance, we think it is going to prove to be sound. That's the one anomaly I think in this project on the cost front, but it's a hard question. How do you get hot water, domestic hot water?
The Efficiency Vermont program we were participating in would not allow us to do an electric resistance hot water heater. And that would have been the easiest solution, but we couldn't go that route.
So Roger Cooney included the website for Coltec. If you're interested in more information about them. And he also says, not all, so we've got different opinions here. Not all vinyl windows are UPVC. UPVC is better for the environment and living things. Okay, I think if I'm correct, we have answered all the questions that have been put forward. And thank you very much, Ethan and Dan, for your very clear answers, and thank everyone for asking so many good questions. Back to you, Guy.
All right. Thanks, Ethan and Dan. If your question wasn't answered, or you think of questions later, Please use this email, admin@seon.info, where you can send your questions and we'll do our best to get back to you. We turn next to a builder's home in Goshen, Massachusetts, a hempcrete house by Village Carpentry and Landscaping and Hempstone LLC. This single-family home aspires to become an affordable and deeply carbon beneficial by using natural building products, materials, including hempcrete, to capture and store more than 12 tons of carbon dioxide in this new healthy home.
Hi there, welcome to the Fuller Hemp House in Western Massachusetts. This is a timber frame home with hempcrete insulation and lime plaster finish. This home features natural, carbon beneficial, reused, and local materials. These factors, along with its bright, flowing, and welcoming open floor plan, are part of what make this sustainable home so special. To start off, let's take a look at the ground up process of creating this kind of home. We can start with the foundation. The Fuller Hemp House has a superior wall foundation system. This is a pre-manufactured wall system that supports the home using a combination of concrete, steel studs, and EPS foam. This system allows for minimal concrete as a footer, instead relying on crushed stone beneath the building. Even though this process cuts down on concrete, a material that generates a lot of carbon emissions, this foundation system is the most carbon emitting component of the entire house. That being said, carbon emissions were heavily taken into account in this project, and the carbon balance of this house would be roughly zero minus this foundation system, which totaled to under 1,400 kilograms of CO2, as you can see in this chart showing the breakdown of carbon storing and emitting aspects of the home. Before we continue, let's briefly discuss carbon emissions and their relationship to building sustainably. This home is a carbon beneficial building, meaning it is made up of materials that absorb carbon dioxide from the atmosphere. The secret is not that it's high-tech or complex. Instead, it is harnessing the power of the plants. These natural building materials absorb carbon dioxide during their life, and that carbon stays locked in the biomass of the plant. Protected in the wall of a structure, these materials keep the carbon locked away from the atmosphere. To get back to the construction process, once the foundation was ready, the frame of the building could go up. As mentioned earlier, this is a timber frame house, meaning that the home has post and beam framing. This was done with local wood, which decreases the amount of energy and emissions needed to get the wood from being a tree to framing a house. Once the framing was completed, the wall insulation could go in next. Hempcrete, which is a simple, non-structural insulation material consisting of dried industrial hemp hurd, a mineral binder, and water, was packed into formwork. The mineral binder has a very interesting relationship to carbon dioxide in that it actually absorbs CO2 as it dries and cures, in addition to all of the CO2 that has been absorbed by the hemp itself. Hempcrete has many benefits. It is completely fireproof, pest-proof, and because of both the hemp and mineral binders within it, reduces carbon dioxide in the atmosphere. Another massive distinction is that hempcrete wall assemblies are vapor open, unlike most typical modern-day high-performance homes, which usually have a barrier that blocks vapor. This means that hempcrete homes naturally regulate their temperature and humidity, making them extremely comfortable to be inside. Once the hempcrete reached the roof, the next step was lime plaster. This finishing material is used because it is vapor open like hempcrete, allowing the assembly to breathe. Lime plaster is on both the interior and exterior of the home. To add color to certain walls, pigment as well as milk paint were used, as these are also vapor open materials, unlike many modern paints. Many materials were reused, including the cabinets and counters, the wood burning stove, and more. Wood from the site was used for flooring, trim, and exterior sills. As the house neared completion and had a sealed air barrier, a blower door test was also done to test the air changes per hour. Now that we've gone through some of the details of the construction process, let's take a tour of the Fuller Hemp House.
Stepping into a hempcrete home, the first thing that we notice is how comfortable, warm, and inviting it feels. The air smells fresh and clean, and even with multiple people conversing excitedly, sounds are even and pleasant. Natural building materials dominate the finishes of this home. Slate from old billiard tables make up the countertops. and local and site-sourced wood defines the edges of each space and frames the view of the surrounding landscape. Let's venture outdoors. A Fujitsu air source heat pump provides cooling for this home, yet thanks to the incredible temperature and moisture buffering capacity of hempcrete, this unit sees very little use. This system was used only 10 times throughout our hot and humid New England summer. This is because hempcrete materials dramatically decrease the heating and cooling demands on this home. Back inside the main living space, you see pine boards lining the walls. This simple alternative to drywall adds warmth and beauty to the space, makes smart use of site-felled trees, and lowers the carbon footprint of the home. A lime plaster finish called Tadillac was used in the shower to create waterproof walls. Local Goshen stone dust creates the shiny iridescent gray color. The timber framing details speak to the craftsmanship and care that has gone into this home. Upstairs, milk paints are used over lime plaster walls to add variety and to set the mood of each space. Sierra triple pane windows bring ample light into each space without sacrificing efficiency. Softwood finishes create a high-end feel without breaking the bank. Even though it looks expensive, this house prices out comparatively to other new conventional construction in our area at $235 per square foot. By combining good design and thoughtful construction with local natural building materials, the owners gain an affordable, healthy home without sacrificing any of the quality of life features that make a house a home. Lime plaster finishes work beautifully with hempcrete walls to provide a vapor-active building system that manages moisture and temperature passively. Good air tightness detailing at the sills, ceiling, and penetrations using plaster-ready products from 475 ensures that this carbon-smart home is also energy smart.
So the main priority when I was designing this home was to make a home that was comfortable and simple. But it evolved from there because I was introduced to the opportunity of doing hempcrete by Jennifer Martin of Hempstone. And I've always been interested in doing a natural building. I've just not found it practical most of the time. So I was really excited with the opportunity to be able to do sort of a simple, functional, and affordable home that was also a natural building and had this added benefit which I hadn't even considered until we sort of got onto this topic of the, being able to do carbon sequestering. So, the whole design process was obviously sort of a progression, and I started trying to sort of work with a bunch of other people, a few other designers in the beginning, and kind of concluded that a lot of them just weren't that interested in taking these sort of ideas of carbon sequestering and natural building seriously enough. And I ended up doing most of it myself, with the assistance of Hempstone for some of the detailing on the hempcrete and plaster specifically. Did my own layout. I did my own timber frame design. I had the assistance of my wife for a lot of sort of the final details as far as like how the bathroom was designed and stuff like that. But even though I had attempted to work with an architect for some of the detail work, that didn't end up working out. I ended up having to basically do it exclusively on my own. So it was, but it wasn't that bad actually. I thought that with a foreign material like hempcrete, the design process would be challenging beyond my capabilities as an upstart design builder. But actually, I think it worked out really well, and the detailing was not excessively complicated for a small to medium-sized house. Living in this hempcrete house has been really, really phenomenal. The air temperature has been super well regulated. We've had very little operational costs, even though this is not, by any means the
most energy efficient house that one could build by sort of a numbers standpoint, the functional operation of it has been really very good. It could probably be more airtight, but that's sort of on me. You know, but the monolithic nature of the insulation has been really amazing. With just one wood stove in this house, 1,500 square foot house, it has managed to keep all the rooms, including rooms same floor, far away, you know, basically the same temperature. And I really attribute a lot of that to the monolithic nature of the hempcrete itself, because really there's not much airflow. So these rooms that are sort of in the back of the house are not getting air moving to them from the wood stove. That heat is transferring through the actual material mass of the house, which is really a fascinating phenomenon. You know, one thing that I've become a nerd to is the smell of the house, which, you know, to me it's very neutral. It's my house, but basically everyone that I've had come visit this house has said, wow, this house smells great. You know, it's the pine wood, I think, plays a big role of that. The lime, it has this unique smell. But the main thing I think that a lot of people sort of are probably noticing is that it doesn't smell like mold, you know, and it doesn't smell like off-gassing plastic. It doesn't smell like carpet, you know. So there's sort of this thing where one of the benefits of living in this house is not necessarily all the things that it provides, but also a lot of the things that it doesn't have. So yeah, it's been really, you know, it's been really great being in a house that's sort of so simple and functional.
So that is the Fuller Hemp House. We appreciate all of those watching, and we want to thank every individual who was involved in creating the work of sustainable art that is this home. It takes a village, but it is very worth it.
Are you tired of paying high costs to keep your home comfortable? Drafts, chills, gusts of wind, and moisture can cause discomfort in your home as heating or cooling escapes. Our goal at Farnham Insulators is to make your home as comfortable as possible. Making your home more comfortable will save you money as a result. We help prevent your hard-earned money from escaping into your attic and eventually out of your house. We use a variety of techniques to keep your home comfortable and improve indoor air quality. We combat the problems in your attic, basement, and walls that allow energy to escape. By reducing moisture infiltration in your basement, we help keep your home warm and dry. Insulation and air sealing help prevent heat from escaping your home. We install gutters that move water away from your home, and we provide a warm coat of insulation to keep you protected from the elements and feeling cozy at any time of the year. Visit FarnhamInsulators.com today to start your journey to a healthier, more comfortable home.
Do you have a concrete foundation? Rooter Foundation Repair stops leaks from cracks in the wall and around septic and water lines and stabilizes both concrete and concrete block walls. We can often provide quotes from pictures texted to us at 802-579-9309.
Sierra Pacific. Windows that never compromise. Our mission? To do it right. To never compromise. To make the best windows and doors you can buy in the most sustainable way possible. From seed to delivered product.
At Marvin, we make more than just windows and doors. We make fresh breezes and nightlights, relaxing retreats, open invitations, and peace of mind. At Marvin, we make windows and doors inspired by how you live, so you're inspired to live well.
Visit WW Building Supply, your local Marvin retailer in Newfane or Wilmington.
At Friends of the Sun, we sell, install, and service all of our products. You see, selling wood, pellet, or gas stoves aren't sidelines for us. Neither are window treatments, awnings, or outdoor furnishings. They are what we do. We're knowledgeable about the latest technology in heating and cooling, and we display only those products in our showroom. Once we understand your needs, chances are good we can show you the right product. Please visit us at www.friendsofthesun.com.
Building Right is me, Pete Yost. My work encompasses all aspects of building performance with an emphasis on moisture control and heat transfer. I work with architects to review design and specifications, and I work with homeowners, builders, and remodelers to do initial assessments of buildings or investigate failures. Go to www.building-right, that's right with a W, to see what I can do for you and your building.
Now I'd like to introduce you to Shelby Howland, the homeowner and owner of Village Carpentry and Landscaping, and Jennifer Martin of Hempstone, who are eager to take your questions. Jonathan, take it away.
Okay, so first of all, I'm going to backtrack to the last topic. Mike Maines says, PVC versus UPVC is a common misperception promoted by European window suppliers. So we're getting into the weeds on this one, and I'm just going to say that PVC versus UPVC is an open question. Bye. So I had this question, and Gary asked this question. What was the final blower door result?
So I'm happy to take that. I want to start by saying how it began, because hempcrete is a biocomposite that is actually pretty porous. It relies on a matrix of hemp hurd that knit together. Each hemp hurd is bound together or coated in a lime-based binder, and then it's bound together with water as the catalyst to help create that set. And it's kind of like a sponge. So we did an initial blower door test after all of the hempcrete had been installed, but some of the air tightness details at the very top hadn't yet been finished. The top meaning the ceiling, because the hempcrete on this building is simply the wall system. The roof insulation is blown cellulose, or perhaps, yeah. So our first blower door test came in at 23.8 air changes per hour at 50 Pascal. Now we expected that, and what that means is that the wall system itself, just the hempcrete, creates a great insulation as well as a thermal mass. It works on both principles. So we relied on a lime plaster exterior air barrier of 1/2 inch. So after our initial application of lime plaster, we went down from 23.8 to 3.0 air changes per hour. And again, that was before we had put in our recessed lights in the ceiling. We hadn't taped all of our Intello. There was some more buttoning up that was done, and we eventually got to 2.0 when we were finished.
Okay. Another question from Gary. How is domestic hot water provided?
I guess I'll take this one. Basically, we just have a hybrid hot water heater that's it's a heat pump and electric. Sort of the simplest solution to that problem. And we do find that since we don't have any heat in our basement, we don't have a furnace, and the hot water heater is in the basement. The heat pump itself actually doesn't really work that well in the winter because our basement gets cold, even though the rest of the house stays warm. So we do have to change it over to straight electric for 3.5 months out of the year.
Okay. So I have a couple of questions of my own. I noticed that the foundation insulation you referred to as EPS, but what I saw was extruded foam. What's your, I mean, I know that that foundation system uses extruded foam, not EPS.
Well, they're both extruded. They're both extruded foams, right? It's styrofoam. It's styrofoam, which I believe is EPS.
No.
But
well, they are two different products, but that's okay. I just wanted to. So does the cost that you quoted, the $235 a square foot, include all of your labor, or
so
did you work for free?
Nope. So that cost actually includes the tally that I did for the house includes all the materials with overhead, all the labor at actual labor rate, even though I was building it as a company, and my profit and overhead statement as well.
Okay.
So it is the price as if I were building it for somebody else.
Right. And then another question that Katrina had is, what's the roofing material? You didn't mention that.
It's standing seam metal roofing.
Okay. And Jennifer mentioned kind of as a side that you the ceiling or the rafters are insulated with cellulose. Is that correct? And what's your R value up there?
Right. So we have 18 inches of ceiling cellulose on a basic we just use a basic truss system, and it's their attic trusses with 18 inches of cellulose. So it's R60 or whatever, R58.
So it's loose fill.
Loose fill, not dense pack. Correct.
Okay.
One thing which nobody actually is not going to be a question, but I just wanted to correct it from the video. She said Sierra windows, but they're actually Malik windows, which is a Polish company. They're a European tilt turn window. They are triple pane, as you mentioned, but yeah, so they're Polish.
Okay. Carly Chickering asks, do the interior walls have lime plaster over the sheetrock?
Yeah, so all the interior walls were basically built as though they were a conventional house, just 2x4 sheetrock. Nothing fancy about that. And we did do lime plaster over all of them because we wanted all of our plastered surfaces to blend. We just used sanded primer, just basic box store 5-gallon primer. Put a little sand in it, and it worked out really well. In the bathroom downstairs, we did Weldabond instead of sanded primer, and it actually didn't work quite as well as the sanded primer did. So,
all right. She has another question. Not long ago, it was difficult to justify importing hempcrete, and we couldn't grow hemp locally, nor did we have the equipment to chop it. Are you able to source these things locally now?
I'll tackle that one. So we are still in the very early stages of hempcrete in the United States. In fact, before 2018, it was not legal to grow industrial hemp, which is a fiber-based and a grain-based hemp. And so we are still learning as farmers how to grow these materials, and the processing is actually still behind the farming. In terms of specifically for hempcrete, which is a waste product from the fiber and grain industry. Basically, you're taking most of the biomass, the core of the industrial hemp plant, and chopping it up. And we require a little bit more sieving and grading than pet bedding, for example. So at this point, there are several processing plants in this country that Hempstone in particular is working with to try to get to production grade, building production grade hurd, but we're not there yet. So at this point, we're still importing either from Europe or from Canada while we develop those supply chains. And in the process, we're still very early in the development of hempcrete. We have less than 200 hempcrete buildings in the United States. So we're still proving the concept, getting the information out there that this is a viable alternative. we expect to see local, regional supply chains with regional growth of industrial hemp in the next 3 to 5 years. So we're not there yet. We are moving in that direction. And we're fortunate, both Shelby and I are fortunate to be a part of the U.S. Hemp Building Association, which is a national organization of building enthusiasts that are helping to get hempcrete in the building code, get an ASTM standard, and develop that processing and supply chain. It is coming. And the thing that is exciting about starting a new building industry is that we have the potential to do things different than what we were doing before. So instead of using an industrialized agricultural system, we could be developing a regenerative agricultural system as we're developing this new industry. And that's pretty cool.
Okay, great. So let's see, several more questions. Lisa Holderness says, I'm curious about the foundation too, that metal. I missed the name. Can it be done with a different foam product?
I would say that's a question for Weaver, who's the manufacturer of Superior Walls. I think that probably there's a reason that they would probably use, so it's Styrofoam as the brand, and I guess that is, so EPS and XPS, there's a whole science behind it, which maybe Jonathan knows more about than I do. And I know one thing that we've looked at was sort of the table of carbon emissions from foam, and obviously polyiso is very high carbon emissions. It's a really bad problem. Both XPS and EPS are actually not as bad as one might think. EPS is a little bit lower carbon footprint. And I think probably because of, it's, whatever the R value calculation they were doing, it's a commercial product. So it's not like something you can do on your own. So changing the foam is not something you can sort of do willy-nilly. It's only 2 inches in my basement because the idea is that I'm going to be eventually doing mineral wool or cellulose in the bays. And also just going back to somebody's mentioning this, the metal, it's not actually metal studs structurally. Those are just attachment metal for putting wallboard up. There's a tension rod in each of those bump outs, which is the thing that's creating the actual structure. There's a little bit of concrete and a pre-stressed metal tension rod at every 24 inches. There's only about 2 inches of concrete on the outside of the entire foundation. And then it's got a pre-applied stucco surface.
Okay. Thoughts on sprayed hempcrete versus hand placed, from Mike Maines.
I'll tackle this one. There are actually 4 different ways to apply hempcrete. It makes it the most versatile natural building insulation because it can be packed, like we saw here, cast in place, which is a wet apply application. It can be sprayed. There's also 2 dry installations. One is block, it's just simple masonry unit, and the 4th option is panels. There is a time and place for cast in place compared to spray. We like to say in the industry that spray is fast, loud, and messy. So if you're building a large structure or a development, you're not necessarily in an existing neighborhood, and you have enough space on site to have your machinery move around the building, spray is a really good option. We've used a couple different spray systems this year on both a big project in Cape Cod and 2 small projects in New York, and they do have their place. Cast in place has the benefit, although it is slower, it has a very human scale approach. You can talk to your colleagues while you're building, and it's also cleaner, and it's probably, meaning cleaner, it's more user-friendly for the installers. So it really matters your site conditions, your local site area, and what is the point of your project? What kind of scale are we talking about? And what are some of the other critical factors?
Okay, great. Thanks a lot for all that information. Bob Swinburne says, and I've used this company myself, recycled foam is available out of Massachusetts for a really low carbon footprint. I've used polyiso in a large gut rehab for my daughter, and I used quite a bit of that from Massachusetts. To me, this doesn't compare. This is not comparing hempcrete with anything else. It's just, Bob is just noting that that's possible. So Sam Snellings says, there's an early photo in the presentation that showed the timber frame with what looked like a lightweight construction roof on top. What drove the decision to not timber frame the upper roof? I may have misunderstood the photograph.
No, you understood the photograph perfectly well. Truss roofs are fast and affordable. And since I was doing a flat ceiling on my second floor with an insulated, attic floor, I figured why waste a whole bunch of time and money putting in a bunch of hidden timber framing. In general, roof is the hardest part of a building to timber frame, in my opinion, because if you want to do exposed timber frame, you end up having to build an entire second roof on top of the timber frame, which is just waste. It is just no other way to say it. It's a waste of time, resources. It's for aesthetics, right? I mean, like if you really, if you want the beauty, but like from a purely functional standpoint, it's not necessary. So for me, it just made more sense to just throw, conventional trusses on top of the timber frame.
Okay,
Jonathan, we have one minute to go.
Right. So I'm going to ask, Ethan Cole asked, could hempcrete be installed against the inside of the foundation wall below grade? What are the installation parameters? Chris Murphy, and I'm just going to bundle these together. I'm new to the idea of a vapor open structure like this hempcrete. We're also in Massachusetts, and it feels like, except for those few blessed spring and fall weeks a year, we're fighting uncomfortably high or uncomfortably low dew points. Why would I want to be vapor open to that?
I'll answer the question as somebody who's now lived in a completely vapor open hempcrete house, is that we had much more moderated humidity basically the entirety of the year. And I think it's because of the moisture holding aspect of the hempcrete. And when we say vapor open, it's not like water's just wicking through the walls. It's that when you have, when you're breathing in your home, in a normal plastic wrapped home, when you're breathing in your home, it's either condensing on your walls and turning into moisture there, or it's going to go through your insulation layer and condense on the back of your sheathing, which is going to turn to water and rot your sills. I mean, there's so many problems. And if you don't have a completely pinpoint tight interior vapor barrier, you're going to end up with moisture in your walls, which is going to create mold problems and many other issues. But the thing is, because these walls have this vapor storage capacity, it means that during the winter, all winter long, we were running the wood stove, and we never got below, I think it was 32% humidity at the end of the winter, which my dad's house is more conventional. He was at like 7% or 6% most of the winter, so he just dry. I mean, I've gotten, to me it's like, oh, wood stove, it dries out the house. I don't even think that anymore, because I'm like, oh, my wood stove is on, and I don't feel dry. And then in the summer we never got above 76 or 77% humidity, which a lot of people, I mean, most of the homes I've lived in most of my life, in the middle of the summer, you're sweltering at 92% humidity inside your home. So it's true, if you do a perfectly tight sealed plastic box, with a managing HRV and all these sorts of technological systems, you can manage your humidity in your plastic case. But in this case, we also can just manage it naturally.
Jonathan, what I'm going to do is cut in. I know Ethan had some questions, and what we'll do is we'll get back to Ethan with the answers. He wanted to know about hempcrete installed against the inside of the foundation wall and below grade, and then what are the installation parameters. So we'll get back to Ethan because we do need to move on.
And there are actually some other questions which we'll get to later too.
And so what we'll do, once again, if you have further questions, just make sure we'll log these questions, but also make sure that you type in additional questions to admin@seon.info, and we'll get back to you. So thank you, Jennifer and Shelby. It was great. Okay, we're going to turn next now to our final project, which brings us to the deep energy retrofit of a rundown house in Bellows Falls. The homeowners, Steve Crofter and Laurel Green, were the general contractors. And this resurrected house and material, or excuse me, this resurrected house used material to lock in carbon. They increased the energy efficiency, they resolved the water problems, and they built vegetable gardens right in the village of Bellows Falls. In all of this, really to set up their lives to have a lower carbon footprint and to live a sustainable lifestyle.
This is the story of Laurel Green's and Steve Crofter's quest to embrace an environmentally sustainable lifestyle in light of the climate crisis. In 2018, they lived on a farm where they had to drive everywhere. Their vision was to live in a home that would reflect who they are and what they love. It would help them live their values of caring for the earth and people. In 2019, they made a decision to move to Bellows Falls, a densely packed old mill town on the Connecticut River. It's a walking village with a rail and bus service. Because of their prior experience with renovating older homes, they purchased a rundown home that had southern exposure for gardening and solar. They now walk to stores, ride the rails, and use their electric vehicle. They've eliminated all grass and have 14 vegetable beds on their front and side yards. The gardens were developed as a way to help stabilize the water cycles by slowing, sinking, and storing water in the ground, while also producing a large portion of their food. They wanted their home to be part of the solution. This guided them in their decision to reduce greenhouse emissions as much as possible. Their goal was to be net zero, generating as much energy as they use. Steve and Laurel worked with Efficiency Vermont and the Zero Energy Now, known as the ZEN program, to benefit from expert advice and help in obtaining all available incentives. With that knowledge, they were able to integrate their high-performance features of the house so that it worked as a system and that it was all electric. Their salvage home had multiple challenges: rotted sills, leaky roof, water in the basement, broken windows, and no functioning heating system. Holes in the foundation required immediate attention. Water came off the roof and ran directly into the cellar, leaving a delta of mud on the basement floor. Mineral deposits from effervescence were pronounced on the basement walls. Taking the recommendations from Efficiency Vermont, they first had to address the water problems. The foundation was repaired. An underground roof was built using 3 to 4 foot wide rubber fabric installed underground and pitched away from the house, 1 inch per foot, with a gravel top layer to avoid splashing. The basement windows were eliminated. Inside the cellar, they created a perimeter drain that slopes to a sump hole. The crawl space and basement floor were covered with water-resistant barrier. Enclosed cell foam was applied to the walls. Above grade has an R value of 30 and below grade R22. In a recent 5-inch deluge of rain this summer, the basement remained dry. Laurel and Steve did most of the work themselves in almost all phases of the renovation. They had their work cut out for them in removing all the old insulation and lath all the way down to the wood sheathing. As you can see from the huge pile of bricks, 2 chimneys were eliminated, minimizing air leakage. They removed all fuel-burning appliances, including a broken fuel oil boiler system and a broken wood pellet stove. A 275-gallon oil tank was drained and removed from the site. They removed most of the asbestos and lead paint and encapsulated what they couldn't remove. They removed all existing wiring, some knob and tube, and installed a 200-amp service panel with all new circuits. All the plumbing was replaced. Once the mold and moisture problems were solved in the basement and the crawl space, they redesigned the living space with aging in place in mind, wheelchair-friendly, with bedroom and bath on the first floor, and performed the necessary structural repairs. Work began on the envelope, focusing on insulation, air sealing, and the replacement of the downstairs windows. The wall thickness was increased by adding 2.5 inches of polyiso and 8.5 inches of dense packed cellulose, making the exterior walls close to 1 foot thick, with an R value of 40. Polyiso is a rigid foam insulation used in roofing and wall assemblies. The house did not have an attic, but mostly a small open space. To increase the insulation in this open space, they lowered the ceiling on the second floor and then added cellulose up to the sheathing. Ventilation was provided by having an airspace above one section leading to a screened opening. The overall R value is 68.5. To ensure the greatest air sealing performance, they used a new technology called AeroBarrier. This is a computer-controlled system that detects air leakage when the space is pressurized and emits a fine aerosol spray of synthetic permeable sealant. This performs as an air barrier around ceilings, walls, windows, doors, and around electrical and plumbing fixtures. It can cover cracks up to 1/2 inch and as small as a human hair. The estimated blower door test was between 2 and 2 1/4 air changes at ACH 50. That's air changes per hour at 50 pascals. This shows that there was a 58% reduction of envelope leakage. All first floor windows were replaced with fixed triple pane windows with a U value of 0.19. They did not see a need to have windows that opened when they already had an air exchanger. They removed 4 windows on the north side of the house. Their upstairs windows were already double pane, and in the winter will be covered by removable inserts to minimize air leakage. The mechanical systems consist of 3 Mitsubishi single-zone cold climate heat pumps along with exterior compressors. A Renew Air ERV system model EV130 is used for ventilation. Steve and Laurel installed the ductwork for the ERV themselves. A heat pump water heater located in the basement is used for domestic hot water. Humidity-controlled fans remove moisture from the bathrooms, and the kitchen has an induction range and oven. They have 7.36 rooftop solar arrays, south and west facing, with an estimated production of 8,506 kilowatts per hour. The system powers all of the home's electrical needs, including recharging their electric vehicle. Laurel and Steve also take advantage of Green Mountain Power's reduced rating system for charging their electric vehicle during off-peak hours. Locally sourced pine was used throughout the house. The kitchen is now complete and the project is winding down. Laurel and Steve's intent was to set up their lives with a low carbon footprint, even though it is not an easy task with the deep energy retrofit. But in the end, they accomplished their goal of living in a home that supports their environmentally sustainable lifestyle.
Efficiency Vermont has an impact on the amount of energy we use as a state, encouraging people to make improvements to their own houses, and they work one-on-one with businesses as well.
Efficiency Vermont helped us in achieving our goals of becoming more energy efficient and saving money. In addition, we just live in a more comfortable home.
The services that Efficiency Vermont offers are accessible to all Vermonters.
I think most people think of Efficiency Vermont, they go into a hardware store or wherever they're buying their light bulbs and they can see a rebate. But they sent an individual on site who did an audit, and then they provided it some advice on upgrades that could be made that would yield long-term electrical savings.
After we first moved into our home and realized we were burning a ton of fuel oil to heat, we started to look into avenues of becoming more energy efficient.
Why waste money on energy that you can spend on other things?
The world is changing, and we all need to rise to meet the challenges that these changes will bring. Sustainability and resilience are two of the most important tools we have in navigating our future. Brattleboro Savings and Loan has been living these values for over 100 years. As a certified B Corp, we've invested heavily in reducing our carbon footprint and, more importantly, doing the right thing for our communities. Whether you're buying or building a new home, consider putting your money where your values are. BratBank.com. Member FDIC, Equal Housing Lender.
Hey folks, Nate Gusikoff here from Zone 6 Energy, just basking in the glow of a blower door. Zone 6 offers building envelope consulting, blower door testing, diagnostics for all sizes of buildings. We also install aero barrier, as you'll see on the Crofter and Green project, so give us a holler for anything involving air tightness of your building envelope.
Hi, I'm Katrina Wilson, here at Integrated Solar Applications, also known as ISA, in Brattleboro, Vermont. ISA has been serving in and around Windham County since 1975. In-house, we design, install, and service solar photovoltaic, which is solar arrays either up on your roof or on the ground, Mitsubishi Hyperheat cold climate heat pumps to meet your heating and cooling needs. Stiebel Eltron hot water heaters meeting your hot water needs. Battery energy storage systems giving you power when the grid is down or allowing you to do self-consumption management. We here at ISA look forward to becoming your partner in making your home more comfortable and sustainable. Please give us a call at 802-257-7493 or find us at isasolar.com.
The SECU is a values-based financial cooperative that is open to everyone who lives or works in Vermont. Our vision is to inspire a movement that brings people together to empower the possibilities for greater financial, environmental, and social prosperity. With offices throughout the state, we offer a variety of loans and programs for customers looking to finance larger solar, home efficiency, or home energy improvements.
Okay. Now we're going to turn to the questions and answers, and assisting are the homeowners, Steve and Laurel, along with Katrina Wilson of Integrated Solar, who worked with the Zen process. Jonathan?
Sorry. We have one question so far. I hope more come in. Carly Chickering asked, I would like to hear about the cost of the, and I don't know what this is, TADELAKT. Maybe it's a typo. And how you kept your labor costs down for that, please.
I wonder if that was the question for the last project or for this one, but we can talk a little bit about our costs. It was interesting until this morning, we just realized it might be useful. We never actually figured out a cost per square foot. And we're pretty sure that by the time we're all done, and we're not finished yet, but that we'll come in somewhere around $100 per square foot. Of course, that's not paying us anything for our labor, because we did a lot of the work ourselves, and it was pretty significant. But if you count our labor is worth, if you just consider how much of a good time we had renovating this house, that we did that for the pure joy of it, then we came out pretty cheap in terms of getting a pretty nice house for $100 per square foot.
So I wanted to make sure that that Katrina could give us an overview of what the Zen program is.
So the Zen program is a Zero Energy Now program. So it's money from the state trying to get homes to be net zero, or at least start down the path to being net zero. So to qualify, there's some tests that you need to do, and I've written them down so I can remember them. So it's 10, 50, 50. So you have to reduce your airflow in the home by at least 10%. You have to reduce your fossil fuel and grid electric by 50%. And then at the end, your total project energy load needs to be derived 50% by renewable energy. So the ways that this is often done is you do energy efficiency first, insulating, water management, and air sealing. We often get much more than 10% reduction in airflow. Reducing your fossil fuels is getting off oil or propane and doing a heat pump for the main source of your heat, and using either wood or some fossil fuel for just backup. And for renewable energy, it can be a pellet boiler, geothermal system, a solar electric, solar hot water.
Okay.
That just sums it up.
And how is that regulated or ascertained?
Regulated or asserted? I think what you mean is how is it managed?
Right.
So there's 5 to 7 general contractors in the state that can put their projects through this Zero Energy Now program. So you can go to zeroenergynow.com, I believe, in Vermont, and you can find the contractors. We're one of the contractors here in Southern Vermont, and we only do a mile radius, an hour radius around Brattleboro. So that's how it starts. And then we would walk into a home and we would make suggestions and make recommendations. We don't do any energy efficiency. So you always have to start with a blower door test, because that's the important number before you do anything. And then you end with a blower door test after all is said and done. And there's a lot of reports to fill out, but the general contractors do all of that.
Okay, great. Carly Chickering says she was at that question that I asked was for the last house. So Mr. T asks, did you ever feel like it would have been easier to do a new construction rather than the renovation?
Yeah, I can take that one. It really wasn't a question for us. We really wanted to live in Bellows Falls, where there's bus service and train service. It's a walkable village. It's about 1 mile north to south, 1 mile east to west. And we wanted to be in the town. And literally, we looked on Google Maps, street by street, to find an existing home that had enough space so that I could have about 1,000 square feet of no-till raised bed garden. And this was the house that was available. We wrote a letter to the owner. The house was not for sale, but we wrote a letter to the owner, and the owner said, never got a letter like that before, and proceeded to sell it to us. You know, he'd raised a family here, and the house they had not been able to do upkeep, and it was in very poor condition. The town considered it a salvage house. And so this was the project we took on. You know, it's sort of interesting. I always thought I never would want to do new construction because there's too many decisions. But doing a deep energy retrofit also has probably the same number of decisions. We just didn't make them all up front. We kept thinking and growing. We really lived into the house. We learned a lot as we went through the process.
I think certainly on a day-to-day basis, you know, especially on a bad day on a gut rehab site, of course you wish you were doing new construction instead. But at the same time, you know, we've got to reuse a house from an environmental standpoint. You know, to knock this house down and start with all new materials would be a waste. And, you know, there was some sort of combination there. You know, there are parts of this house that we took apart and threw away, but for the most part, we made do with a given situation, but added elements to it to make it pretty darn energy efficient, considering where we started.
We also reused materials that were in the building. We changed where the wall structures were, for instance, and we denailed and reused all that lumber. Oh my God. We really did as much as we could to repurpose existing materials. For the underground roof outside, we found somebody who had, part of it was used rubber roofing that had been removed from another site that we reused, and somebody else had excess rubber roofing left over from a project. So we didn't go buy new rubber roofing to do it. As any place we could, we did a reuse, a repurposing as much as we could. Our cabinetry in our kitchen is all, they were taken out of a house that was being renovated because somebody just wanted to update to something more modern. They work fine for us. They look great. So a couple examples.
Okay. So Sam Snellings asks, what aging, and this thing keeps moving around, what aging in place elements were important to you and what uses are planned for the second floor?
That's a great question. Can I keep going?
Sure.
We're both, you know, we're in our 60s when we started the project, and we continue to have birthdays. So aging in place was very much a thought, very much in our minds. All of the first level of the house all have wide doorways. We have a wheelchair accessible bathroom, and we have bedroom on the first floor. So bedroom, kitchen, bathroom, all on the first floor is very much part of living in, you know, setting it up to live in the future comfortably here. To enter from the garage is only a 4-inch
step
elevation gain. To enter from what we're using as the front door, we'll need to build a ramp, and the east entrance, we're going to have steps and not have that but have that accessible to the outside except for walking. But it will be neither of the porches, I'm not saying this well. The east porch is existing but needs to be replaced. And the main porch is in the design phase. Basically, it's going to be a porch with a wheelchair ramp, accessible ramp to it, included as part of a whole outdoor room space that we've designed.
And in terms of the second floor, it is true at this point we do have a stairway in the house, which upstairs does include a room that Laurel uses for her study. But if we were both in wheelchairs and couldn't ever go up the stairs, the upstairs could certainly be a caretaker's quarters. Could be used for guests, for other uses besides for ourselves.
Right, and there are 2 baths in the house, one downstairs and one upstairs.
Great. So, Mr. T asks, I'm not sure exactly what he means, but I'm just going to read it as it is. Did Integrated use a solar K inverter?
So that's a solar inverter. So we actually didn't do the solar on Laurel and Steve's house. Southern Vermont Solar did. If we had done it, we would have used a solar edge inverter unless they were using a simplified battery energy storage system, and then we would have used the solar inverter.
Okay, so maybe Steve and Laura can expand a little bit on exactly what your solar system is.
I'm not sure that we actually have the details in mind or at our fingertips. Looking, but
the size of their solar system is a 7.36 kilowatt system.
Yeah. One thing I can say about it is that again, it's a little hard to say because the solar system was installed while we weren't even, before we were even living here, but we're still under construction for part of that. But at this point, we've gone through, you know, almost 2 years, and it looks to me like the amount of energy we produce is going to equal, I think we're coming out pretty even on the amount of energy we're producing with the solar versus how much we're using on a year-round basis. So we're pleased with that. Yeah. If it's not exactly enough, it's awful close. So.
And do you have just as a point of information, do you have a Tesla wall battery?
We do not have battery storage. It's something we're considering, but we haven't done that yet. So we're just we're grid tied and using the grid, but putting solar power back into it.
Right. Okay, as with Peter Bergstrom asks, as with the hemp home, does the basement get too cold in the winter to use the heat pump function of your water heater?
Yeah, so our experience has been that it's working fine. I was just noticing, and I think we did this, now remembering we did this last winter, that we've set the temperature during the most of the year for 120 degrees, and it seems plenty hot for taking showers and so on. And I just noticed yesterday the shower felt a tiny bit cold. And so I think we'll, as we did last winter, I think we'll turn it up to 123 degrees for the winter. But we didn't have any trouble producing hot water last winter, and I assume it'll be the same this winter. So,
great.
So.
What financial help did you get from Zen?
Do you have that?
Yeah, so yeah, when we qualified for the Zen program, we got an incentive of $8,000. So that was part, you know, we received incentives and rebates totaling $17,600 in all for this project. A lot of that was from Efficiency Vermont, Green Mountain Power, and then the Zen program.
Okay.
Jonathan, we're coming to an end.
Okay.
So maybe one more quick question.
How long did this project take?
We're still working on it. We've been going at it for 2 years, and that included, you know, doing all of the demolition to start. And at this point, we're fully living in the house. We're trimming and building interior doors and that sort of thing. And then we have the exterior finishing to do, and the porches and the ramp, as I explained. So we'll probably be busy with it through next year. So 3 years.
Great. Okay. Thanks, everybody.
Yeah, thanks, Laurel, Steve, and Katrina.
Thank you.
All right. Well, this is bringing us to an end of our 3 projects, and we at SEON hope that this gives you the kind of information that you're using and like to use when you think of your construction, whether they be new, renovations, or deep energy retrofits. It's important to understand that when we talk about high performance building, we're not just talking about the results. We talk about the results, but also the interrelationships of building processes, of construction processes, the technologies that are used, and the high performance products. Everything in these homes that you've seen is interrelated. You can't have energy efficiency if you don't give equal intensity to water and vapor management. Mechanical ventilation is essential when we're talking about tight homes. Drawing down carbon by using proper material with low embodied energy products is essential for sustainable living. Solar without attention to energy efficiency misses the point of using less energy. Our builders and architects and designers are systems thinkers with an acute awareness of the detail. It's the little stuff, and oftentimes the little stuff, that can trip up a project, yet observable only months and sometimes years down the road. Our website on our website under management, you can find a list of the builders who are members of SEON. We'll be sending out a feedback form of this program and hope you will give us the kind of feedback for future programming. And again, to stress, to follow up with any of our presenters or with questions, please email us at admin@seon.info and we'll forward your requests to them. This concludes our program for today, and thank you for attending. All the best. And as the winter time occurs and comes upon us, be well, continue to follow all safety measures, and enjoy our upcoming holiday seasons. Thank you.